we all know is 2x. And on the right, we have sine x times cosine x. Sine x cosine x plus sine x cosine x. Exactly this. Well, if you add sine x, if you add something to itself twice, you get 2 times that. This is 2 sine x cosine x. Sine x cosine x plus the same thing. Sine x cosine x, that equals 2 sine x cosine x. Here is one of the double angle formulas. The other double angle formula, well, the cosine of x plus y, we know that this is cosine x times the cosine of y minus the sine of x times the sine of y. Well, what happens when y is really x? What if y is x? What if y happens to be x? Well, on the left, we have cosine of x plus x, but x plus x is 2x. Notice I'm getting these formulas for free. I'm just memorizing, say, this one, and then I replace y with x. And bingo, I get that formula. Okay, on the right side, I have cosine x times cosine x. That's cosine squared x minus sine x times sine x. Oh, that's sine squared x. Here is a double angle formula. The two that have the check marks, those are your double angle formulas. And now, this last one we can write in a couple of other ways. We know that sine squared x plus cosine squared x is 1. If I bring the cosine squared x over, I get sine squared x is 1 minus cosine squared x. So another way of writing sine squared x is 1 minus cosine squared x. Well, I'm going to write that right there. This is cosine squared x minus 1 minus cosine squared x. Well, this is cosine squared x. I have to take away 1, I just did, at least I denoted it, and I have to take away a negative cosine squared x. Well, taking away a negative is the same as adding a positive. That is, I'm going to add cosine squared x. And then I'm going to erase because I need the space. And now I'm going to say that cosine squared x plus cosine squared x is 2 cosine squared x. And I will not forget to take away the 1. This here is another way of calculating the cosine of 2x. There is yet a third way. Remember, sine squared x plus cosine squared x is 1. Okay, I'm going to solve for cosine squared x. I'm going to bring the sine over. Cosine squared is 1 minus sine squared. So I'm recopying this equation right here, but instead of cosine squared x, I'm going to write 1 minus sine squared x. So cosine of 2x is equal to, I just copied this, equals cosine squared x is 1 minus sine squared x. Take away another sine squared x. That is, I'm taking away 2 sine squared x's. Here is another formula for the double angle formula for cosine. Right. Let's write these down nicely. Let them be close by. Right underneath one another. And then, of course, we're going to talk about tangent. Oh, we don't really need the top one. So we'll just keep putting them on top. We know we just derived that the sine of 2x is 2 sine x cosine x. If you love memorizing formulas, memorize all of them. Me, I have better things to do at my time. We know that cosine of 2x is cosine squared x minus sine squared x, which is the same as the 2 on the bottom. 2 cosine squared x minus 1, or 1 minus 2 sine squared x. This is cosine 2x. We have a few different ways of getting cosine of 2x. Now, for me, if somebody asked me what the tangent of 2x is, I would say, oh, I know that. It's the sine of 2x over the cosine of 2x. That is, I would pick one of the formulas for sine 2x, namely 2 sine x cosine x, and I would pick a formula for cosine squared x. I'll pick the first one for cosine squared x. I can use any one of them, doesn't matter. Personally, that's what I would use for tangent 2x. Possibly the denominator would have been one of the other formulas for cosine 2x. But let her see what the book is going to say. The book is basically going to say the following. The book is going to tell you to think about what the tangent of x plus y is. The tangent of x plus y. Well, that is the tangent of x plus the tangent of y divided by 1 minus tangent x times tangent y. But if x or y, let's call it y, if y becomes x, if y is x, then the left side becomes the tangent of x plus x, or the tangent of 2x. And the right side becomes tangent x plus tangent x. Oh, that's 2 tangent x. And the bottom becomes 1 minus tangent x times tangent x. Well, tangent x times tangent x is tangent squared x. And that's the formula that you will see in your textbook. Okay, you should know these formulas. You should know them, or at least be able to derive them. I equate that with knowing them. Some people, they're called geniuses, they walk around and they remember all these formulas. Okay, you don't need to. If you're a genius, remember them. It's easy for you. Now, we're going to talk about reduction formulas. A reduction formula takes the angle. For example, if you were given, say, the cosine of 4t, and you were asked to write this, okay, so the angle, you take cosine of the angle. The angle is 4t. If you were asked to write this as an expression, a trig expression that only involves t, that is, an acceptable answer might be, an answer would look like maybe 7 sine of t plus 81 cosine of t divided by 13 tangent of t minus 3 cosecant of t. Okay, it is not equal, trust me, but the point I'm making is the angle is now t. That is, the problem is they're saying write this, an equivalent, something that equates to this, something that equals cosine of 4t, but the angle is no longer 4t. Whatever the angles are, it should be t. So an answer might look something like this. That is, it only has t's involved. So the formulas we use is called the reduction formula because it takes the angle from 4t and it reduces it to t. Okay, so let us figure out what the reduction formulas are. they're actually all up there. They're actually all up there because here I have angle 2t or 2x, and I reduced it to x's. Here I have the angle is 2x, and I reduced it. Okay. So if somebody something disturbing me here, if you must know. Alright, so let's do the problem I just stated. I was really leaning towards something else, but I did also want to do this. If you do have the cosine of 4t, you should think of it as the cosine of 2 times something. And that something happens to be 2t. So it's 2 times 2t is 4t. Okay, well, how about we look at this formula? X can be anything, but your angle better be 2 times that anything. Okay, that is x is 2t. X is 2t. So this is cosine squared of x minus sine squared of x, but x is 2t. So I reduce the angle. These formulas right here reduce angles. So now I have 2t as my angle. But you know what? I don't like this formula. You know why? This formula has cosines and sines. The ones below it, this one only has cosines. This one only has sines. I use this one. I lied when I said I'll use the top one. I'll use that one. It only has cosines. So I get 2 cosine of my x, take away 1. Take away 1. My x is 2t minus 1. So I reduced the angle. It used to be 4t, now it's 2t. We're moving in the right direction. I might even give you half credit for this. Now, think of cosine squared 2t as what it really is. Cosine of 2t squared. But it does say take away 1. But you know what? I know exactly what cosine of 2t is. Okay? Instead of x, I have t. It's 2 times cosine squared of t minus 1. That whole thing gets squared. So, coming up here, please, this is 2 times, when you square that, you will get 4 cosine to the 4th t minus 4. I'm going to need a little bit more space in order to write it. 2 times, when I square what's in the brackets, I get 4 cosine to the 4th t minus 4 cosine squared t plus 1, and then I take away 1. Well, 2 times that is 8 cosine to the 4th t minus 8 again, minus 8 cosine squared t plus 2 times 1 is 2 minus 1. 2 minus 1 is plus 1. Here is my answer. And I'm only taking cosine of t's. Here I'm only taking cosine of t's. Okay, for example, if they told me that cosine of t is 1/3, and they asked me to find cosine of 4t, I would have to do everything I just did. I'd have to do everything I just did. And then wherever I see cosine t, I plug in, I think I said a third. That is, this would become 8 times a third to the 4th minus 8 times cosine t squared plus 1. I'll leave the arithmetic to you. But as I told you, find cosine of 4t. If cosine of t is equal to a third, this is what I would do. I would get this formula right here. And I would definitely have used this formula because it involved cosines. If they told me that the sine of t was a third, I would have used this formula. Okay? Right here, the cosine of 2 times some angle. I would have said that it is equal to 1 minus 2 times sine squared of that angle, 2t. Okay. So now, what I want to do is, at this point, so we talked about reducing the power. Now we want, or reducing the angle. We reduce the angle. We need to derive a couple of other formulas. We talked about how you can reduce the angle, and this comes up many times in our calculus 2, in integration. So let me number these formulas so we can talk somewhat intelligently. 1, that 2 come out, that's 2. This one is 3, 4, and 5. I'm going to play games with 3 and 4. Play games with 3 and 4. Cosine of 2x is equal to 2 cosine squared x minus 1. I want to solve for cosine x. The first I'm going to solve for 2 cosine squared x by bringing in the 1 to the other side. So the right-hand side is just 2 cosine squared x. Now the left-hand side, you might want to say that it's cosine 2x plus 1. Now that's not wrong, but someone might reasonably think that the angle is 2x plus 1, which is not the same as cosine of 2x and then adding 1. Okay, so to remove that possibility, instead of adding 1 at the end, I'll add the 1 at the beginning. The cosine 2x is understood to be positive, and I'll add 1. Okay, but that didn't come out so neat looking, sorry. So we add 1 to both sides. Here's the 1 I just added, and I added it to plus cosine 2x. So I get 1 plus cosine of 2x. On the right-hand side, I get 2 cosine squared x. Now I divide the right side by 2, and I divide the left side by 2. Here's a formula that comes up all the time in calculus. All the time. Okay. So for example, if your square button breaks on your calculator and somebody says to you, what is cosine squared of 60 degrees? And you say, oh my God, my square button doesn't work, what do I do? Of course you can find cosine of 60 and then multiply by cosine 60 again. Or you can say that cosine squared of any angle is 1 plus cosine of 2 times that angle, better known as 120 degrees, divided by 2. You can compute 1 plus cosine of 120 degrees divided by 2. Okay, so that's the formula that comes up. Now, if you take the square root of both sides, the square root of the right side will be cosine of x is equal to plus or minus the square root of the other side. This here is called, well, in a moment, it will be called the half angle formula. It will be called the half angle formula. For example, if I take cosine of x is equal to 1 plus cosine 2x over 2, the square root of it, plus minus. And wherever I see 2x, I call it u. Well, if 2x is equal to u, if I divide this by 2, I get x. And if I divide the other side by 2, I get u over 2. And we now know x is u over 2. So in this formula, wherever I see x, I put u over 2. And wherever I see 2x, I put u. So the cosine of x, u over 2, is equal to plus or minus the square root of 1 plus cosine, well, 2x is u, over 2. This formula right here is called the half angle formula. This is called the half angle formula. Okay. Now, let me use formula number 4 like I promised. Let me use formula number 4, and we're going to derive something very, very similar. We're going to use the exact same techniques. So you need to be writing down these major formulas as we derive them. We know that the cosine of 2x is 1 minus 2 sine squared x. I got it right from the line above, and I want to solve for sine squared x, or sine x. So let me solve for 2 sine squared x. Since it's negative in front, let me bring it to the left. And since I only want 2 sine squared on the left, I'm going to bring this to the right. So when I deal with the 2 sine squared x, since it's negative on the right side of the equal sign, when I bring it to the left, it becomes plus 2 sine squared x. The 1 is on the right side, it's going to stay on the right side. The understood plus cosine 2x, when I bring it over to the other side of the equal sign, it becomes minus. And then I divide the right side by 2 and the left side by 2. That 2 disappears. So then, if sine squared x equals this, then sine of x equals plus or minus the square root of this. 1 minus cosine 2x over 2. So now I'm going to make this substitution. I'm going to write the formula right here. Instead of x, I write u over 2. Instead of x, I have every right to put u over 2. Equals to plus or minus the square root of 1 minus cosine of 2x. But 2x is u divided by 2. Okay, let's get rid of everything on this page except the 2 formulas that we have. Let's try that again. The 2 half angle formulas is all that's going to remain when I'm done erasing. Now, we have this plus minus on the right-hand side. We need to decide on a case-by-case basis whether to keep the plus or the minus. Okay. Now, this is somebody asked me, what is the cosine of 22.5 degrees, and you cannot use a calculator, and it has to be exact. Well, what I would think is, 22.5, 22.5 is 45 over 2. Now, it starts to look like this here if I'm assuming that u is 45. That is, if u is 45, this is cosine of u over 2. The cosine of u over 2, I'm just reading the formula, this formula right here, is plus or minus the square root of 1 plus cosine of u, 45, over 2. Now, before we go any further, we have to decide if it's plus or minus. Well, 22.5 degrees is in quadrant 1. What's the 90? Yes, 22.5. Well, everything is positive in quadrant 1. In particular, the adjacent and the hypotenuse are positive. Positive over positive is positive. That is, I now know that the sine, the cosine of 22.5 is positive. Okay, if it was a different angle in a different quadrant, I may have kept a negative. I may have kept a negative. Okay, so we know it's plus, so I won't write the plus. But I will write down what cosine of 45 degrees is. Let's look at our, put it up here. Let's look at our 45, 45, 90 right triangle. 1, 1, square root of 2. The cosine of 45 is adjacent over hypotenuse. The cosine of 45 degrees is 1 over the square root of 2, which is the square root of 2 over 2. It's the square root of 2 over 2. Now, in this term, there's no denominator. In this term, the denominator is 2. And in this term, there's no denominator. If you want to say there's a denominator, fine, it's 1. For 1 in the top, the denominator is 1. But let's not even say that. There's only one denominator in each of those terms, and it's 2. That is, the LCM of just 2, the least common multiple of 2, is 2. So I'm going to denote for now that I'm multiplying each term by 2. Why? Because all my denominators go into it. 2 times 1 over there is 2, plus the 2's cancel out, so I just get square root of 2, and of course 2 times 2 is 4. So I get the square root of the top divided by the square root of the bottom, which I happen to know. There is the exact answer for cosine of 22.5 degrees. That's an example of using the half angle formula. If somebody asked you what is the sine of 15 degrees, remember that the sine of u over 2 is plus or minus the square root of 1 minus cosine of u all over 2. Somebody asked you, well, what is the sine of 15 degrees? Using the half angle formula. We either calculated the sine of 15 degrees or cosine of 15 degrees earlier by using the difference formula. We said the sine of 15 degrees was equal to the sine of 45 minus 30. So we didn't have to do that. We can think of 30 as something, 15 degrees as something over 2, namely 30 over 2. The 30 is my u, because sine is sine, and I'm going to call 30 u. So I have the sine of u over 2. It's exactly what this is. And this is equal to plus or minus the square root of 1 minus cosine of u, which is 30 degrees, over 2. We'll talk about the plus or minus in a moment. The cosine of 30 degrees, well, look at the 30-degree triangle. It's 1, 2, square root of 3. The cosine of 30 degrees is square root of 3 over 2. It's square root of 3 over 2 over 2. Now, which sign should I keep? Which plus minus? Should I keep plus or minus? Since we're taking the sine of 15 degrees, which is in quadrant 1, our angle is in the first quadrant. The sine, so here's 15. The opposite is positive because it's going up. Hypotenuse is always positive. Positive over positive is positive. Keep it positive. Now, I'm going to multiply each of those circled entries, each of those terms, by 2. 1 times 2 is 2. This times 2, we rig the 2's to cancel. And 2 times 2 is 4. I have no idea what the square root of 2 minus square root of 3 is. But I definitely know what the square root of 4 is. It's 2. This is exactly what sine of 15 degrees equals. And for some reason, I think we got a different looking answer when we did sine, when we calculated sine of 45 minus 30. I don't think it looked like it. You know what? They're the same. Whatever we got is going to be exactly the same. Just using algebra. I don't think we had a square root in the whole, I don't think we took the square root of the whole numerator. Okay, those are ways to deal with the half angle formulas. Okay, what about the double angle formula? Let's consider the double angle formulas, how we can use examples. Let's work out some examples that use the double angle formula. For example, if you were told that the sine of x is equal to 3 over 5, and x is in. This means is in. X is in quadrant 1. X is in quadrant 1. Okay, and they say find the sine of 2x, find the sine of 2x, find the cosine of 2x, and find the tangent of 2x. Okay, well, let's draw a little picture. We know that x is in quadrant 1, so here's my angle x. And the sine of x is opposite over hypotenuse, 3 over 5. And you should remember that's 4. 3, 4, 5, right triangle. This is to the right, it's positive. This is up, it's positive. This is hypotenuse, it's always positive. So what's the sine of 2x? Well, it's 2 times sine x times cosine x. It's 2 times sine x. And you can get sine of x from the triangle, or you can say, oh, that one's easy, it was given, 3 over 5. Times the cosine of x, which is adjacent over hypotenuse, 4 over 5. Multiply the denominators, you get 25. 2 times 3 is 6, times 4, multiply the numerators, get 24. If the sine of x is 3/5, and x is in the first quadrant, then sine of 2x is 24 over 25. Okay, cosine of 2x, well, one formula is cosine squared x minus sine squared x. Well, cosine squared x, well, cosine x we just calculated. Or you can say it's adjacent over hypotenuse. It's 4 over 5. That's cosine x. So we want cosine x all squared minus sine x all squared. Sine x was given, top left, it was given as 3/5. So we do our arithmetic. 4 squared over 5 squared minus 3 squared over 5 squared. In subtraction, if the bottoms happen to be the same, keep them the same. Subtract the numerator. 16 take away 9, or 9 from 16, not 16 from 9. 16 minus 9 is 7. There's that answer. The tangent, don't even dare use the formula at this point. That is the formula that we wrote down that had tangents in it. That is, tangent at 2x's, whether you write this down or not, is this. But the nice thing is I know what sine 2x is. I just calculated it. It's 24 over 25. And I know what cosine of 2x is. I just calculated it. It's 7 over 25. Because I already did all the work. You don't even have to write this. You can say in your head, tangent of 2x is equal to the sine of 2x. But that's what I just circled, sine of 2x. It says the sine of 2x is 24 over 25 over cosine of 2x. In division, if either the numerator or the denominator or both are fractions, don't divide. Keep the numerator the same. Change division to multiplication. So we're no longer dividing, and flip over the denominator. 25 over 7. The 25's cancel out. You get 24 over 7 as your final answer. Let's try one more like this. Okay. Physically erase my whiteboard. So somehow you have to know which quadrant the angle is in. And here we're going to use our technique that we learned earlier. Suppose I tell you that the cosine of t is equal to 12 over 13. Okay. And I also tell you, for example, that the sine of t is greater than 0. That means it's positive. So, in determining which quadrant t is in, this statement tells me the cosine of t is positive. Why? Because 12 over 13 is positive. And this tells me the sine of t is positive. Well, where is cosine positive? Cosine deals with the adjacents. Deals with the adjacents, the x's. It's positive in quadrant 1 and 4, and it's negative in quadrant 2 and 3. Adjacent is positive in quadrant 1. Hypotenuse is always positive. So the cosine, which is adjacent over hypotenuse, is positive. Same deal with quadrant 4. The adjacent is positive, hypotenuse is positive. You divide them, you get positive. So we know that t is in quadrant 1 or quadrant 4. Now, in quadrant 2, for completeness, their adjacent is negative, hypotenuse is always positive, cosine is adjacent over hypotenuse. Negative over positive is negative. Same game in quadrant 3. Okay, now, the sine of t is positive. And 2 and 3 failed because the cosine of t should have been positive. Now, the cosine, it deals with the opposites. Deals with the opposites, which I'm highlighting. Well, I'm telling you it's positive. Positive here and here, and negative here and here. That is, t is in quadrant 1 or 2. T is in quadrant 1 or 2. We pick the common answer. We're in quadrant 1. We're in quadrant 1. T is in quadrant 1. So now that we know where T is in, we can draw our triangle. T is an element, or T lies in quadrant 1. T is in quadrant 1. So I draw my little diagram in quadrant 1, and cosine is adjacent over hypotenuse, 12 over 13. And you should know a 3, 4, 5 right triangle, that is 3 squared plus 4 squared is 5 squared. And any multiples of those, so that can multiply each side by 7, 21, 28, 35. 21 squared plus 28 squared is 35 squared. Should you walk around knowing those multiples? No. But when you see 21, 28, 35, you say, you know what? That's like a 3, 4, 5, 7 times. Okay, but you definitely should know 3, 4, 5. You should also know 5, 12, 13. I wrote down the 12 and the 13. This is 5. An angle is called T. And since it's up, it's plus 5. Okay, now I can answer this. The sine of 2t is equal to, the double angle formula says, it's 2 times the sine of t times the cosine of t. 2 is 2. Sine of t is opposite over hypotenuse. Cosine of t is adjacent over hypotenuse, or you can say they gave us that. And 13 times 13 is 169. So I'll change that in a moment. I wrote 165. 2 times 5 is 10. Times 12 is 120. It's 120 over 169. And that cannot be reduced. Okay. Now, the cosine of 2t is a number of formulas. I tend to use this one. But I wrote down 3 different formulas for cosine of 2t. Okay. Now, cosine squared t means cosine of t all squared. We just calculated cosine of t. You want to do it again? Look at the diagram. You still get 12 over 13. But we want to square it. Minus sine squared t. That means sine of t all squared. The sine of t is 5 over 13. Now, it's a little bit sloppy. I was thinking they told us what sine of t was. They told us what cosine of t was. That is, cosine of t is 12 over 13. They told us. So 13 squared is 169. 12 squared is 144. Minus 5 squared over 13 squared. And since the denominators are the same, we keep them. And 144 minus 25 is 119. Sounds a bit small. No, it's 119. Okay, so there's your answer. Now, for tangent of 2t, it's sine of 2t divided by cosine of 2t. But I have the sine of 2t. We just calculated it. It's 120 over 169. And the bottom is cosine of 2t. But we just did that. It's 119 over 169. In division, if either the top or the bottom or both are fractions, don't do division. Keep the top the same. Change the division to multiplication and flip over the bottom. 169 over 119. The 169's cancel, and you get 120 over 119. That's the tangent of 2t. If they bother to ask you, remember the reciprocal, a sine of any angle is cosecant of the same angle. Well, you just flip over the sine of 2t. It would be 169 over 120. And you can get the remaining two exactly the same way. So let me write down all the formulas so you have it in one place. We talked about a lot of formulas today. I admit that. But then again, this is what trigonometry is. It has lots of formulas. The sine of 2t is 2 sine t cosine t. The cosine of 2t is cosine squared t minus sine squared t, or 1 minus 2 sine squared t, or 2 cosine squared t minus 1. This is the formula for sine 2t. This is one of three formulas for the cosine of 2t. The tangent of 2t was 2 tan t over 1 minus tangent squared of t. Again, I would just say it's this divided by any one of those three. That way I don't have to remember yet a new formula. The half angle formulas, they say the following. Or this, I don't write it down wrong. The half angle formula says the sine of u over 2 is equal to plus or minus. And you need to decide if it's plus or minus. This one is 1 minus cosine of u over 2. And if you have cosine of u over 2, this is equal to the square root, plus or minus the square root of 1 plus cosine of u over 2. Now, if you look at the last two, they look the same except for the sign in the numerator, in the middle, minus and plus. Well, when it's cosine and this is cosine, you have plus. When this is sine and this is cosine, you know, cosine and cosine matched, so we put plus. But sine and cosine don't match, so we put a minus. That's how I would remember it, if I was to remember that. And when I was taking trigonometry, I probably remembered it. Okay. But this is not it. So the top three, if I call them three, those are double angle formulas. These two here, those are the half angle formulas. And then the other two that you should know, if it is two, is the one for lowering powers. We derived at some point that sine squared of x is equal to, I can answer that one, 1 minus cosine 2x over 2, and that cosine squared of x is, I guess, 1 plus cosine 2x over 2. Okay. You should know these formulas. They're going to come in handy. Okay, you should definitely know these handful of formulas for doing trig identities. Okay, that finishes up the section on double angles, reducing angles, and